Okay, so let us do a brief introduction to probability. Okay, so before we get into the main probability thing, let us just understand some basic definitions and all. Okay, so the first thing we have to deal with is what is an experiment. So experiment is any process that generates data. Okay, so anything what you do and it can give you some data as an output over there, that will call an experiment. Okay, like for example, playing a game of cricket or playing a football game or anything, right? So what will happen there? At every in cricket, at every ball you bowl, there is some consequence of it, right? Some runs are scored, right? Some there's a speed of the ball, some information you're getting about the speed of the ball, right? Not only that, you can also cover this thing like which direction the ball went after it hit this thing, batsman hit it. Okay, now all these things, some data you can collect for every ball of the match. You can collect some data, right? So that becomes one experiment. Also, another experiment you can conduct is like when you are going from here to home, right? Along the way, you can make many observations, right? You can make observations about like if you are traveling by bus, you can make an observation like how many people are traveling with you along with you in the bus, what is the speed of the bus, how many bus stops are there along the way, right? Um, yeah, and so on. So whatever you do, you can collect data like that. Not only that, you can also collect other data like what kind of advertisements you saw along the way on the highway, right? Then you can also how many advertisements you saw, how many were of a particular type, like how many were of a hotel, casino, some automobile brand, this thing, restaurant, or some hotel or something like that. Okay, like this you can keep on making some counts over there, right? Or some information you can collect along the way. Okay. So the data which you are collecting, it may be a numerical one or a categorical one. Okay, so numerical means number data you are collecting, categorical means you are collecting some other data. Like category data, one example will be like if you are counting the kind of advertisements, right? So depending on what kind of advertisements you saw, like how many advertisements of an hotel you saw, how many advertisements of a what do you call a restaurant you saw or some casino you saw, right? That is categorization over there. So counting them as what do you call that, restaurants, casinos, hotels, or automobile, whatever. Okay, so you're doing some categorical counting. In case of playing the game of cricket, if you kind of try to classify the shot which was played, whether it was a pull shot, sweep shot, and all, okay, according to that, there's some classification over there. Okay, so that becomes categorical data for the experiment. Okay, and all this data, whatever you're collecting, it is subject to some chance or uncertainty. Okay, it's like not 100% sure that you will get the same thing again and again. Okay, like whenever you're playing cricket or something, you might get a different consequence on every ball. Okay, the speed might be different, the shot played might be different, the run scored might be different, and this is completely unpredictable, right? So it's subject to chance and uncertainty. Okay, so there are three main types of experiments. So three main types of experiments which we'll be coming across in our examples and with our problems which we'll be solving. So one is called a designed experiment. Designed experiment is what you do is it's like conducting a survey. Okay, so you design certain questions which are to be asked to the particular target audience, and then they give their corresponding responses. Okay, like for example, you want to take a survey to find out which is the most preferred brand or something, or what, not rather brand, what are the factors which go in deciding what kind of mobile phone a person will buy. Okay, what are the factors which go there? So you all tell me now, what are the factors which you all will look into? Huh? What C? We're talking about mobile phones, no? Okay, display quality. Then what else? Huh? Battery life or battery capacity. We'll have to count it separately because, yeah, processor. What else? Huh? What quality? What quality? Build quality, yeah. What else? Huh? Okay, customer support. Is that really an existing thing? Anyways, sometimes it becomes useful. What else? What you were saying, number of SIMs? No, I assume all phones in India are dual SIM by now. What availability? Affordability. Okay, means price basically. Okay, what else? Okay, we'll look into only these things: battery, and the durability means build quality, affordability, price. Okay, screen quality and battery life and processor. Right? Okay. So now you can ask, when you are designing, you want to ask these questions to people. There are two ways to do this. One, you can directly ask them, does build quality matter to you? The answer will be yes, no. Does screen quality matter? Does processor matter? Does battery life matter? Yes or no? Right? So you'll get all your answers as yes or no this thing. So this is one way of conducting this survey. Right? And then you can conclude so many percent said yes here, so many percent said no here. Okay? Clear? Another way of doing this is you give all these five or six options. That was on battery life, battery capacity, screen quality, build quality, okay, and tech support and all these things. You write all these things down and you tell them to rank them, which is more important for you. Right? For some people the camera is the most important. Right? For some people the screen size, the screen quality. Right? So everyone has their own this thing over here. Right? So we make them rank these things, and accordingly then we'll decide, accordingly we'll see what is the most ranked thing. Okay, so that is one way of designing the experiment. Both of them will give you some conclusion. The conclusions will be slightly different from each other, because in one place you are ranking them, so doing a comparison between all the factors. Second place you are doing just a yes no comparison. Okay. So that was a designed experiment. The other thing of a designed experiment is like a census survey. The government conducts census, right, every 10 years or something. So in that they ask you all questions about they actually go door to door and they ask questions about how many people are living in this house, how many male, how many female, what is their age and all those things, right? They also ask more questions like what is your income, what is your main business, okay, what is your religion. I think so up till this only they ask. But now there was a demand to include caste also in that and other things in that. Okay. So all these things, if you conduct a survey and you collect the data, accordingly you can take some conclusions from it. Okay. So moving on. Next is an observational study. So observational studies are, or observational experiments you can say, that you're observing something. Like you're observing the game of cricket and you're noting down whatever is happening. Like on every ball, how many runs are scored, right? What kind of shots were played? What was the speed? This is observational. You're just observing what is happening. Okay, you're not designing anything over here. You're not doing anything. Somebody else is playing the game of cricket over there. You're just watching and collecting the information. Okay. Another thing what I told you is when you're traveling by the highway, you're sitting in the bus, right? You're just observing what is the speed of the bus, how many people are traveling with you, how many bus stops are there. You're observing that. Nothing else you're doing there. Okay, the next one is retrospective studies. Okay, so retrospective studies is like basically retrospective, the word means past. So based on some past information what is available with you, you're taking some conclusions over there. Okay, so what kind of conclusions can you get on this? Or like let's say, so for example, you have the monsoon data for the last 7 years or monsoon data for the last 7 days also. Based on that you can have some conclusions of how much rainfall was the total rainfall in those 7 days. Okay, what is the weather pattern, what is the highest temperature, lowest temperature, what is the wind direction, all that information you can collect. That is all based on what you had in the past. Okay, you are taking some conclusions from whatever data is there from the past. Okay. Yeah, also one retrospective study is you once you finish collecting the census data, and after like some years you can look back at it and take some conclusions. Like for example, we can say in 1951 India's population was so and so. 2021 India's population is now so and so. But this becomes a retrospective study. You neither designed it you didn't design the survey. The survey was conducted at some other time. You are just taking a conclusion from the existing information which you have of the survey, census survey. Okay. So we will just call them as statistical experiments or just experiments in brief. Okay. So now let us go further to the next thing, that is called a sample space. So the set of all possible outcomes of a statistical experiment, they are called as the sample space. Okay. And we denote the sample space by capital S, capital S over there, it looks like small s. Okay. And each outcome in the sample space is called as an element or a samples point. Okay. Like as I gave you an example, during the survey, census survey, they go and ask people questions about various things. One of them is they ask about the religion, right? So when they ask about the religion, there are certain options which people choose for, right? One is you can go for Hinduism, Christianity, Muslim, Sikh, Jainism, Buddhism. I think so up till Judaism is counted in India. Okay. So how many? 8 are counted. Then after this there are options like atheist, do not want to disclose or something like that. Okay. So it's up to you if you don't want to disclose or not. Okay. So the sample space will be all these options which are answers to the question. Okay. Same way, like we'll see some more examples. You finished writing? So some more examples on this. Just a moment. Okay, so let us see some examples on this sample space. So let, for example, you toss a coin. What are the possible outcomes? Heads or tails you can get, right? So the sample space is only head or tail, right? Next, second thing we can look at is rolling a die. Okay, first I said we'll take is tossing a coin. Here the sample space is either head or tail. Right. Second thing we'll look at is rolling a die. Here the sample space will be what? Huh. 1, 2, 3, 4, 5, 6. Grade of a student. No, die is one. No, dice is plural. No. Die is singular, right? Die is singular. Dice is plural. Grade of a. Yeah, so what are the options you'll have, by the way, over here? What are the options you left for grades? I'll remember only F, like as if that's your target or something in life. It starts from O or A over here. O. There's O plus or something. It starts at O, then it goes to A plus. Then directly F. This is all right. I think so. There's an R also, right? R means you have to repeat it or something. Okay. Why is everyone sitting in this corner only like today? Okay. So basically, in cricket we'll go now. There is a ball is balled. What are the possibilities? What can happen? It can be a dot ball and you can score a 0. Right? What else can happen? You can get 1 run, 2 runs, 3 runs, yeah, possible sometimes. 4 runs, 6. That's all? Huh? Yeah, what are the other possibilities? Huh? You can have a wicket also. Can you score runs and get a wicket? Yes, no, in case of a run out it happens, no? Yeah, no. So 1 plus wicket, 2 runs and a wicket. I don't think so anyone will try 3 runs and get a run out. So this much is enough. Then other things are now no balls. Can you score runs on a no ball? No ball only we'll discuss first. Can you score a run on a no ball? Yes, no. So it will be 1 plus no ball. We can get 2 plus no ball. Then you can also have 4 plus no ball. 3 I doubt will happen. Yeah, 6 plus no ball is also possible. Right now? Huh? Dead ball will be, it is like cancelled delivery, no? So you won't count that. Wides are there now. Can you score run on a wide? How many? 1 plus wide. Yeah, I will repeat the same thing as above. You won't get 6 plus wide, huh? That is too much. Wide cannot go for 6. Okay. Okay. What else you said? By is no. So there can be a by without a run, so that becomes just a 0. Okay. So there can be 1 by. So basically, by is when the ball passes by, when you get a run out of it without a this thing. Okay, without touching the bat. Okay, so there can be 2 buys. 3 buys looks like a very difficult possibility. 4 buys does happen when the wicketkeeper misses to catch the ball. Yeah, any what other possibilities are there? 3 buys will happen, you think? Actually, to score 3 buys, no, three on the wide, no, you require really bad fielding, huh? No, because if you go to see, no, you get 3 runs only when there is an overthrow. You rarely get a 3 run on the normal circumstances. Okay. What other possibilities are there? Huh? No, that will go as a wicket only, no. What else? Huh? Have you missed out anything? 6, 9, 14, 18, 22. Is there something which I'm missing? Okay, so we'll just take this as the total set. What happened? So this is going to be the sample set for all this thing. Okay, let's go back now. Just writing. So the points in the sample space can be denoted as a list or as a tree or by a rule. Okay, so the points in the sample space can be denoted as a list or by a tree or by a rule. So actually what I've done here is I've made a list over here. This is called a list because I've written down all the names of all the members of the set. Okay, so this is called as list format. Okay. Now if you take this example number 5. Selecting a student. This is an experiment to select a student from the university. From the university. So what will be the sample space? Sample space, what it will be? Huh? No, just O grade. So what you will do in the sample space here, you write down the names of all the students who are eligible to be selected, right? Whatever number of them are there. So this will be the list method. Okay, where you will write down the names of all the student. The other option is a rule method. In this what we'll do is, this will write down as x is a university okay. So this is what we call as a rule format of writing down the sample space. Okay. The other option is like writing using a tree. Like for example, take this example. Uh, yeah, tossing okay. So one way, if you write in the list way, this will become what are the possibilities here? You get both heads. One gives you, first one gives you head, second one gives you tail. First one gives you tail, second one gives you head. Okay. Or both give you tail. Okay. Sorry, there's no rule thing for this. The other option is we can draw this as a tree. Okay. So the other option is you write this as a tree. The way to write this is like this. You toss a coin, right? There are two options. What happens? You get a head on the first one or you get a tail on the first one. Then you toss it again. This will give you with a head again or a tail. Okay? You toss it again after getting a tail. Either you get a head now or you get a tail. Right? So what are the possibilities? You tossed a coin first, you got a head, then you tossed it one more time and you got a head. So your final outcome is H and H. Okay? You tossed a coin first, you got a head first, then you got a tossed it again and then you got a tail. So that gives you this outcome. Or you tossed a coin, you got a tail first, tossed it again, you got a head, you tossed it again here and you got a tail. Okay? So this is what you call as a tree method of listing a sample space. Okay, so this entire thing what I have drawn here, this is your sample space. Okay, that's the same thing what I have written on top there as a list method. Okay, so depending on what kind of problems you are solving, we'll use accordingly. Some problems it's easier to understand using tree, sometimes it's easier to understand using list. Sometimes, what about this thing? Yeah, why did I use the rule method over here, by the way? It's a large set, right? That is one thing, it's a large set and you don't know the names of each and every element. So the safe option is to go for a rule thing. Especially if your set is infinite and it's very large, we don't know each and every element over there, it's better you go for the rule method. Okay? So you just state the condition and you give it. Okay. Okay, so an event is a, moving on to the next subtopic now. An event is a subset of a sample space. Okay, so subset means it is just a collection of some of the elements of the original space. Okay, so it can be an empty set. Empty set means what? There is no element in that, right? So it's an impossible event, it cannot happen only. Okay, or it can be a singleton set where there's only one element, or it can be a proper set, means there are some elements but not all elements, right? Or it can be the full set. Full set means it's a sure event, means if you perform the next, what do you mean by sure event? If you perform the experiment, you're going to get at least one of the elements in this, right? Because it's a sample space, right? All the elements are already there inside. So if you perform the experiment, one of those elements only will come, no, something new will not come. If something new is coming, that means the sample space is not correct, no, right? So sample space contains of all the possible elements. So whenever you conduct an experiment, one of those elements is going to come as an outcome. So if you take the sample space only as your event, okay, then it means one of those elements is surely going to come, no, so it's surely going to happen. So that's why we're going to call it a sure event. On the other side, you have an impossible event. It's an empty set. It's an empty set, and that's why it can never happen. Okay. Let me just give you examples here. Coming back to this, let's look at this only. Let's look at the outcome of this deliveries in cricket. What is the event of, what is going to be the, okay, we'll write everything here sideways rather than I talking about them. I'm writing sideways, you can write it down now. I'm just trying to refer to this. Okay, so let's talk of events over here. So the first event we'll talk of is getting a boundary. What are the elements in this of getting a boundary? 4 is going to be there, 6, anything more? Yeah, you're going to get this also, no? 4 plus no ball, 6 plus no ball, 4 plus wide is here, no? 4 wide, and 4 buys. Okay. So this is the event A. Getting 8 runs. Is there any element which gives you 8 runs? No, right? So this is an impossible event. It's impossible to get 8 runs on a delivery. Okay, so it's an impossible event. So it's an empty set. Okay. Next, can you get the 7 runs? 6 plus no ball, that's the only one. Yeah, that's the only way you're going to get 7 runs. What about 5 runs? 5 runs will be 4 plus no ball only, right? And 4 plus wide is also there. Okay, so 4 plus no ball and 4 plus wide, that will give you 5 runs. You can write it down. Huh? Okay, Why will get 1 plus 4? You can't run one run and score a boundary also, no? What are you saying? I didn't understand. 1 plus 4, what is it? We didn't count that only, no? That becomes 5 runs, no? That scenario becomes 5 runs actually. It's not, overthrow is counted as runs only, that's not counted separately. So it will become you ran 1 run and then you got 4 as overthrow. 6 can come like that. No, it can come as 4 plus 2 plus 4 you'll get. That will give you 6 only. Okay. Okay, so this is about this. Let's go back about events. Okay, so let us try to do this now. Before going to this exercise, no, we'll do an easier one. See, I told you all about drawing trees over here, right? Six. What example we were? 7. Okay, rolling 2 dice. Okay. So what is the possibilities here now? You roll the first die. You get 1, 2, 3, 4, 6. Then you roll the second die. That will give you again 6 people here. One. So you got 1 on. Okay, so 1 on the first one, 2 on the second one, 3. Okay. Right, so these are the possibilities. I have written only for 1. This will happen for every element like this, 2, 1, 2, 2, 2, 3 and so on. So like this will get how many possibilities in total? 6 into 6, that will give you, there are 6 possibilities for the first die and 6 possibilities for the second one. Right, so total will becomes 36, 6 into 6. Okay. Well, you can sit and write this down, but it is going to occupy a lot of place on your books. So, what happened? Okay, so now can I try this one? Try this exercise. I'll give you 2 minutes. You can try it. So let us see the answer. So see here, for the sake of simplicity, no, I'll write the odd number separately. So I roll a die, I'll write the odd number separately. 4, 6. Okay. So now after this, if you get an even number, you have to roll a dice only, toss a coin only once, right? So this will lead you to H or T. This will lead you to H or okay. But if you do this, you have to do it twice. So you get a head, then you toss again and you get a head. Or you toss it, you get a tail. You toss again, you get a head. H, tail, toss this head again, you get another head, or you get a tail on the second time, get a head. Okay, the same thing has to be done for 5. Huh? Okay, same thing has to be done for 5 also. I don't have place remaining. Clear? So like this, you are going to get 18 outcomes over here. Clear to everyone? How I got it? Got it? Oh, behind you. No, that girl I'm saying. Got it? Okay, so let's go further. Okay, so let us see operations on events. Now this is what we had done in the last class of revision on the operation on sets. One is the complement. Okay. So what is going to be the complement of an event? So complement of an event A with respect to S is the subset of elements of S that are not in A. Okay. Yeah, so these are all the elements which are of S which are not in A. So there is something called a universal set here, that is the sample space. Okay. So elements of the universal set which are not in A. Okay. We denote the complement of A by A apostrophe sorry, A apostrophe, or we write an A to the power C over there otherwise. Okay. Some places they use A bar also, but I won't be using a bar. We'll keep that notation for something else. Okay. So let's just see an example before we go further. Wait, I'll go back to that screen, don't worry. So with regard to that example of cricket over there, consider this set C with regard to that cricket example. So C will take it as the event of scoring more than 5 runs. Okay, what will be the elements of this event? 6 is there. What other options were there? 6 plus no ball is also there. What else is there? Anything else is there? What is this, right? So what will be C complement? It will be the remaining 22 elements over there. Okay? It will be the remaining 21 or 22 elements which are there, that it will be. Okay? If you take a simple example, if you take the universal set as set of students in the class, You take A to be the set of students uh, okay, what will be A complement? The set of students who didn't get O grade. Okay, or you can also write it as set of students who got that remaining alphabets over there, A plus, A, B plus, C, C plus, whatever. Okay, did not okay. So let's go back. So let's go to the next thing, that is on union. The union of two events A and B is an event containing all the elements that belong to either A or B. Okay. So let me just give you a simple example here. If we took the set of students in the class, you take A to be the set of boys, B to be the set of girls. What will be A union B? All the students in the class, right? How much is the cutoff for A grade? 55? 80? 85 and above should be O grade, no? A grade might be from 70 or 75. Seventy-five or 70. Like for example, if you take the union of the set of students who got O grade and union of the students who got A and A plus grade, right? What you'll get? You'll get the set of all students who got above 70 or 75%, whatever that cutoff is over there. Correct, no? Okay, if you take the union of students who have got O grade and the union of, and the students who got A and A plus grade, you should get the set of students who have got above 70. How much it is? 70, I think so it should be. Okay, so I've scored above 70%. Okay. So we denote it by A union B. So okay, so just write down those two examples which I gave you. Union of set of boys and set of girls will give you the full class, right? Also, union of the A and A plus and O grade will give you the set of students who have scored above 70%. Okay? So just write it down in brief, those two examples. Okay, done? Okay, let's go further. So next event is going to be, this is number 3, by mistake it's printed as 1 here, just write it as 3. Third one is intersection. So intersection is the intersection of two events A and B is the event containing all elements that are common to A and B. Okay, so they should be lying in both the sets. Okay, it's denoted by A intersection B. Let us see some examples on this. While we're writing, write fast. Done. So let's move on. Okay, set of students in the class, set of students who got O grade. Then we'll take this P as students okay, you take C to be the where we'll put okay. So what will be B intersection C? Huh? What is it? Okay. No, they can be students living in Perne also, and they come from bus by Mapsa. No? So what you should say? Students who live in Mapsa and then travel by bus. And is important. Okay. Okay. Can you define two more sets and give me an example of an intersection? Okay, if I define D to be the students who so what will be C intersection D now? What will be C intersection D? Hmm? You'll get something here. Can it be a student who is living in Mapsa also and he is living in South Goa also? No, right? So this has to be an empty set, right? Okay. So this is an empty set. So let's go back to this thing. Can you give me another example of an empty set? Two sets whose intersection will be empty. Huh? Another example of an empty set. Any more example? Okay, anyways, we'll continue. Two events A and B are said to be mutually exclusive or disjoint if A and B have no elements in common. Like the one which I just gave you, students living in South Goa and living in Mapsa, they cannot have anything in common. Okay, so we say such events are mutually exclusive. Okay. Okay. Okay, so let us work out this exercise now based on this thing. Okay, try to work out this exercise. I'll give you all time. Yeah, the previous one. So refer to that previous exercise which you have done. Okay, so the first thing was number less than 3 occurs on the die. So what are the possibilities there? It is all this thing, that is 1 HH, 1 HT, 1 TH, 1 TT, and then here is there. This exact same thing repeated with 3 on it. THT, 3H, okay, and then you have 2H and 3, sorry. Okay, so this is the answer to question number 1. Okay, question number 2 is going to be, you get 2 tails. So 2 tails will be the events. Only when you get an odd number, that time only you can have a possibility of 2 tails. Less than 3 they said, beta. Less than 3, so this is not included, sorry. Less than 3 they had said, so this is not included. Two H, 2T. Yeah, so this will be 1T, 3TT, 5TT, 2 tails. So A intersection B will be and this is A. So A intersection B, clearly there is only one element in that, that is 1 T and T, and A union B yeah, sorry, there are more elements in this. That is 3 TT and 5 TT. Okay. So let's continue now. Okay, so let's go to the next thing, that is Venn diagrams. So Venn diagrams is from sets, it's a relationship between events and the corresponding sample space can be illustrated graphically with the help of Venn diagrams. Okay, so we'll directly, wait, before going there. So basically what we are going to do in Venn diagrams, just a revision again. So basically how do you do Venn diagrams? Just remember the rules. First to draw the universal set. Okay. Okay, so first draw universal set. First draw the universal set. Okay, draw the events or subsets of the universal set. Okay. Show. Okay. First draw the universal set, draw the events or subsets, draw the relationship like intersection and disjoint. Okay, so first to draw the universal set, usually we draw the universal set as a square only, but it's not a compulsory rule. We prefer to draw it as a this thing. What happened to her? What happened? Okay. So next is you draw the events as subsets inside it. So subset will go intersection, disjoint, and okay. So if one set is contained inside the other, you draw it like this, inside the other. Okay. If there is an intersection, you draw it like this. Okay, with some slightly overlapping. If there is no relationship between them, then you draw them separately. Okay, clear? Clear about this? So let us see one exercise on this and then we are done for the day. Okay, you all had written this down, no? Okay. Okay. So let us see this example. The resumes of two male applicants for a college teaching position in chemistry are placed on the same file as the resumes for two female applicants. Okay, two positions become available at the first at the rank of assistant professor, filled by selecting one of the four applicants at random. Second position is the rank of instructor, is filled by selecting a random one of the remaining three applicants. Okay. Then just a moment, let me just. No. I was just seeing how many questions are there. What is going on there behind? What you boys are doing there? You are tickling each other or something? What are you doing there behind? I wanted to leave you all early today, but it's raining outside. What to do? I will get wet. I will get wet. We'll wait inside the class only, like for some more time. It's raining very heavily outside. Huh? He went out and came asking. It's raining heavily now. Okay, so what is this notation what they are using here? M to F1 means the second male got the first position. Okay, that's the assistant professor, and the first female got the rank of an instructor. Okay, what will be F1 M2 mean? First female got the assistant professor job, and the second male got the instructor job. Okay, M1 F1 will mean what? First male got the assistant professor job, and the first female got the instructor job. Okay, clear? So let us see the exercises now. Finish writing? Finished? Write fast. Done? Wait, they are writing this thing. Okay, list the elements of the sample space S. What will they be? Let us dictate it orally only. You will get M1, F1, M1, F2. Wait, I'll write it down only, there too many. But there are combinations, no? See, there are four people available for us. One is M1, M2, F1, F2. So there are two jobs available, and the position which they are selected is different. So the order matters over here. Whether you're at M1, F1 and F1, M1, they are two different things. Okay. So what are the sample space here? M1, F1, M1, F2, M2, F1, M2, F2. Wait, let me count. I have not counted myself. F1, F1 M1, F1 M2, F2 and F2. Yeah, M1 M2 will also be there. Is this all? 12, no? Yeah, how to count? There are 12 people here, by the way. See, there are how many jobs available? 2 jobs are available. How many people are eligible for the first job? 4, right? So there are 4 options over here. How many people are eligible for the second job? 3. Because one person is already gone, no? So 3 people are eligible for the second one. So how many combinations are possible? 4 into 3. Okay, so total is 12. Okay, let's go to the second question. List the elements of S corresponding to the event A that the position of the assistant professor is filled by the male applicant. So the first job goes to the male, second job goes to the male or female, it's not important. Okay? Yeah, the first one is the assistant professor. So what is this thing for A? So M1, F1, everything which has M first over here. M1, F2, 6, no? 6 are there. M2, F1, M2, F2, and M1, M2. Second fellow is instructor, no? Sorry. Yeah, first one is this thing, professor, second one is the instructor. Okay, in C it says that exactly one of the 2 positions is filled by the male applicant. Okay. Exactly one of the 2 is filled by a male applicant, both are not males, only one of them is of male, exactly one. So that will be, again this should be 6, right? No, this is 8. This is M1, F1. 8 are there. Okay, that was C. Let's go to D now. Oh, question number D. Oh, wait, what did I write here? Oh, correct. Okay, option D now. Okay, none of the 2 positions are a male applicant. Okay, none of the positions are a male applicant. So none of the positions are male applicants means what? Only females are this thing. So F1, F2 and F2, F1. Okay. Next is what? Okay, now this remaining things I will do fast. Intersection, union and yeah, last one is Venn diagram. Try to do E and F. So the answer to E should be the first line what I had written there in the sample sheet. So remember. Huh? Event is that one. No? Yeah, question B. So the answer of question E is exactly the first line what I had written. You will copy it in the same way. Still raining. I have been ready to forget right about it. I will concentrate. I will not come to class next time. It is really studying. So the answer to E is the first line over here. And the answer to F is what? The answer to E is the first line. Write it again. Okay. Got it? Okay, what will be the last one? How will the diagram look like? Okay, for the last one, A, B, C, D. Okay, this was A union B, A intersection B, sorry. M2 F2. F2. Let's check. This is for this thing. F was A union C, right? M2 F1, M1 F1, M1 F2, M2 F1, M2 F2, M1 M2, M1, and then F1. Yeah, so how will the Venn diagram look here? The Venn diagram, the last question's answer will be like this. A and B, they have something common, right? They have 4 elements common. So A and B. Okay, so A, B. What about C? It has to be isolated because it has nothing in common. Okay, so this will have your thing look like. Okay. Okay, so we'll stop with this. Okay, so that's all for today.